Hello everyone. So this is K. Sandhyarani, Assistant Professor, working in NRCM Engineering College. And in this video, I would like to discuss about Laplace transformation of multiplication by T and division by T forms. So here, first let us try to see multiplication by power of T. So what is this multiplication of power of T? Means, as we have learned like previously, Laplace transformation of standard functions and Laplace transformation of combination of functions. In that combinations, if we have for sure exponential function, first shifting theorem should be utilized. If two functions containing the variables of the same kind like t minus a, then second shifting theorem should be utilized. So in the same pattern, if we have combinations of functions where we are supposed to find out their respective Laplace transformations, in that combination, if we have algebraic term like t square, t cube, then how to evaluate that Laplace transformation of that particular function, let us learn here. And it is named as multiplication by power of t. And it is named as multiplication of power of t. Okay. So if we see the statement, if Laplace transformation of f of t is equals to f bar of s, then Laplace transformation of t power n into f of t is defined as -1 whole power n into n times differentiation of f bar of s with respect to s. Means, if we have here, you see in the example, we need to find out Laplace transformation of t into sine t. So here two terms are in combination, t into sine t. In these two, if you observe, t power 1 is one of the algebraic term involved. So in this case, we can utilize this multiplication by power of t formula. So if we have Laplace transformation of t into f of t, okay, is defined as -1 whole power 1 into one time differentiation with respect to s for the function f bar of s. Okay, when we have t square, then Laplace transformation of t square into f of t. This f of t can be any one of the function. Okay, -1 whole square into 2 times differentiation with respect to s of the function f bar of s. And it continues for t cube, t power 4, so on for t power n also like this. So in our example, what is happening? In our example, t is there. Means we need to differentiate f bar of s only once. So what is this f bar of s? So to find out this f bar of s, we want f of t. Why? Because Laplace transformation of f of t is f bar of s. So here f of t is sine t. So if f of t is sine t, means Laplace transformation of sine t is defined as 1 by s square plus 1. And this is named as f bar of s. So we have f bar of s with us right now. So Laplace transformation of t into sine t is defined as -1 whole power 1. Since we have 1 as a power of t here, one time differentiation, that is d by ds of f bar of s, and this f bar of s is nothing but 1 by s square plus 1. So in this step we applied the formula, that is -1 whole power 1 into one time differentiation of f bar of s. Okay, in the next step we need to differentiate this f bar of s, which is nothing but 1 by s square plus 1. So as we know that, like you see, 1 by x differentiation, d by dx of 1 by x is what? -1 by x square, which can also be written as -1 into x power -2. Okay, the same thing will be applied for this 1 by s square plus 1. Treating this s square plus 1 as x, it can be written as s square plus 1 whole power -1, whose differentiation is -1 into s square plus 1 whole power -2. Similar to this, -1 into x power -2, that is -1 into s square plus 1 whole power -2. And inner differentiation of s square plus 1. Inner differentiation of s square plus 1 is 2s. Okay. Okay. So in the differentiation, we got one subtraction symbol. According to formula, we have another subtraction symbol. Both together, minus times minus becomes plus. Okay. And 2s will remain as it is in the numerator part. And whereas s square plus 1 whole power -2 will be written as s square plus 1 whole square. So finally, the result is 2s divided by 2s divided by s square plus 1 whole square. Okay, so in this way, we can apply this multiplication by power of t formula to the suitable functions where we are finding out the Laplace transform. In the same way, if you see some more examples, okay, if you see some more examples, Laplace transformation of t square into cos t. Otherwise, t square into e power t. Okay, so Laplace transformation of t square into e power t. Here, if you observe this t square, we need to go with the 2 times differentiation of f bar of s. So to find out this f bar of s, first we need to find out what is f bar of s. So according to the logic, f bar of s is nothing but Laplace transformation of f of t. Means here the f of t is e power t. So Laplace transformation of e power t, that is 1 by s minus 1. Okay, so thereafter Laplace transformation of t square into e power t is written as minus 1 whole power 2. Why? Because since we have 2 here, square into 2 times differentiation with respect to s of f bar of s. So therefore, minus 1 whole square becomes plus 1. So d square by ds square of f bar of s is what? 1 by s minus 1. So which can be written as d by ds of 1 by s minus 1. So d by ds of one time differentiation of 1 by s minus 1 is minus 1 by s minus 1 whole square, as we have discussed in previous example. That is differentiation of 1 by x is minus 1 by x square. So again, we need to differentiate this one. Then what happens? This minus 1 will be out, and the differentiation of s minus 1 whole power minus 2 can be written as minus 2 into s minus 1 whole power minus 3. Therefore, finally, 2 divided by s minus 1 whole cube is the required output of this Laplace transformation of t square into e power t. So like this, we can take any sort of function in the place of f of t, and we can differentiate, and we can find out the Laplace transformation of powers of t into that f of t. Okay. So again, if we try to understand, when does this multiplication by power of t should be utilized? Multiplication by power of t formula should be utilized whenever in the given question, if you find t square, t cube as one of the term in the given function. Okay, so thereafter, after finding Laplace transformation of the small powers of t, let us go for next. Another example. So 2 examples we discussed, and let us discuss another example here. Laplace transformation of t square into cos t. Okay, so since we have here t square, what we have to do? We should apply the formula. But because we can observe that t square is one of the term in the given function, therefore minus 1 whole square into d square by ds square into f bar of s. Here we have calculated f bar of s. That is Laplace transformation of cos t. So now hereafter what we are supposed to do? This minus 1 whole square becomes plus 1. In the further step, only d square by ds square into s by s square plus 1 will be remaining. So first derivative and second derivative we can calculate individually like this. Otherwise, we can directly write in the continuation steps. So one time differentiation of s by s square plus 1 will be done by using the formula d by dx of u by v. So d by dx of u by v formula is v into u dash minus u into v dash divided by v square, where this u represents the numerator and v represents the denominator, isn't it? By following this logic, if we try to apply this formula for the differentiation of s by s square plus 1, it is written as s square plus 1 into 1 minus s into 2s divided by s square plus 1 whole square. But because here this is v, differentiation of u, differentiation of s is 1 and s remains same. Differentiation of v, that is differentiation of s square plus 1 is 2s divided by v square. After simplification, we got this. Okay. Again, we need to differentiate this for one more time. Again, we can find this s terms and in the numerator part and in the denominator part. So therefore, for differentiation of this minus s square plus 1. Okay. Divided by s square plus 1 whole square is done by using the same u by v formula. Therefore, v into u dash minus u into v dash divided by s square plus 1 whole square is done. Right? So s square plus 1 whole square becomes whole power 4. So after simplification, we are going to have 2s cube minus 6s divided by s square plus 1 whole cube. So while doing this u by v formula, we should be like very attentive in calculating differentiations in a differentiation. Later on, we need to do the multiplication part, normal multiplication. S square into s square becomes s power 4. S square into 1 is s square. 1 into s square is s square. 1 into 1 is 1. Okay. Again, all the 4 terms should be multiplied with this minus 2s here again. And this 4s should be multiplied with minus s square. The same minus 4s will be multiplied with 1. All together, after simplification, we got this. So like this, all by using the suitable simplifications, we can find out the final answer for the Laplace transformation of t square into cos t. Okay, so this is all about the Laplace transformation of multiplication by powers of t. So after learning about this Laplace transformation of multiplication by t, let us try to understand about division by t. So what is this division by t formula? Means in the given question, we will be observing the function where in the denominator we are going to have this t instead of t square, t cube and all, first t. And here the formula is defined for division by t, not for powers of t. Point to be noticed here. So therefore, let us try to understand the definition. What is this definition here? Laplace transformation of f of t is equals to f bar of s. Then Laplace transformation of f of t divided by t is equals to integration over s to infinity f bar of s ds. F bar of s ds. Therefore, Laplace transformation of 1 minus e power 2t divided by t is one of the example. Means if you observe carefully this function, you see everybody, in this function, denominator is existing. In the denominator, we are having t. So by observing this t in the denominator, we should get an idea that we should apply this division by t formula to evaluate this Laplace transformation. Okay, so let us apply this Laplace transformation for division by t formula for this evaluation of Laplace transformation of 1 minus e power 2t divided by t. So for that, we need f bar of s again. So what is the f bar of s mean? As usual, this f bar of s is nothing but Laplace transformation of f of t. What do you all say? Right? So if f bar of s is equals to Laplace transformation f of t, we should identify what is f of t. F of t is nothing but the numerator part given in the given question. Numerator part given in the question. What is the numerator part in the given question? 1 minus e power 2t. So the solution starts with finding Laplace transformation of the numerator, that is L of 1 minus e power 2t. And according to the same linear property what we have discussed in the introduction part, by applying the linear property, this Laplace operator will be separated for 1 as well as for e power 2t. So Laplace transformation of 1 is nothing but 1 by s, we have written here, and Laplace transformation of e power 2t is 1 by s minus 2. Okay, so now this becomes f bar of s. So immediately what we can do? We can find out Laplace transformation of 1 minus e power 2t divided by t. Okay, so which is equals to integration over s to infinity f bar of s ds. This is the formula. So what is the f bar of s? 1 by s into 1 by s minus 2. And I was separating this integration for both the terms like 1 by s and 1 by s minus 2. And integrating them, we are going to have log s minus log of s minus 2 under the limits s to infinity. Okay, so by applying the limits, first by applying the upper limit, we are going to have log infinity. By applying s, we are going to have s by s minus 2. Here we have utilized one logarithmic formula, that is log m minus log n, which is equals to log m by n. Okay, So log s minus log of s minus 2 is written as log of s by s minus 2 by using this formula. So therefore, after applying limits, upper limit and lower limit, log infinity minus log of s by s minus 2 is obtained, whereas log infinity becomes 0 and leftover term is minus log of s by s minus 2. Okay, and if this minus becomes the power of this, then what happens? Log of s by s minus 2 whole power minus 1. So which can be written as log of s minus 2 divided by s. So like this, we can evaluate Laplace transformation of given questions which possess t in the denominator by using the formula division by t. Okay, so after discussing that example, we have one more example to be discussed here. That is Laplace transformation of cos at minus cos bt divided by t. So therefore, as usual, according to our procedure, we should start our solution with the Laplace transformation of the numerator part, which is nothing but cos at minus cos bt. Okay. Right, which is nothing but again you see, again we have utilized linear property so that we got f bar of s. So therefore now whatever we got, that is s by s square plus a square minus s by s square plus b square becomes the f bar of s. So according to the formula, that is Laplace transformation of cos at minus cos bt by t is written as integration over s to infinity f bar of s ds, where this f bar of s is nothing but this entire thing, no? So this is replaced here. Okay, right. So now immediately this integration will be separated for both the terms, and thereafter if you try to integrate the integrands like s by s square plus a square and s by s square plus b square, we can identify the formula, that is f dash of x by f of x formula in the integration, which is nothing but log of f of x. Okay, log of f of x means the differentiation of the denominator should be existing in the numerator. Should be existing in the numerator. So therefore, to have this differentiation, what we observe is the differentiation of this s square plus a square is 2s. So we have only s here. What we are supposed to do is we need to multiply and divide it by 2 here. Okay, so this 1 by 2 will be remaining as just integration of this 2s by s square plus a square becomes log of s square plus a square. The same thing will be done for the next integration also. 1 by 2 remains as is, whereas 2s by s square plus b square will be written as log of s square plus b square under the limits s to infinity. Okay, and next again here, as we know that log m minus log n is nothing but log m by n, isn't it? So here in this step, if we take 1 by 2 common outside, what we can write here? 1 by 2 into log of s square plus a square minus log of s square plus b square. Okay, everybody. So it should be written as have now log of s square plus b square by s square plus a square by s square plus b square. So now let us apply the limits. When we apply this infinity, it becomes 0, and if you apply s, what it becomes using. Okay, when we apply this infinity will be obtained in the denominator part. So 1 by infinity becomes always 0. So log 0 is 1. No. Here 0. A square by infinity becomes a 0. 0 plus 1 is 1. Here also b square by infinity becomes 0. 0 plus 1 is 1. Means log 1 is the term left obtained after applying the upper limit. Next day, let us substitute this s in the place of s. So the same term will be obtained. Right? Log 1 is 0. So therefore, what is the next term? This 1 by 2 will be multiplied for this term directly. So minus 1 by 2 into log of 1 plus a square by s square divided by 1 plus b square by s square. Nothing but this. This one only actually. No need to do this. It's not compulsory. So therefore, what we got now? The answer is 1 by 2 into log of s square plus b square by 1 plus divided by s square plus a square. Okay. So like this, we need to evaluate the given function cos AT minus cos BT by T. So after this, what we can understand is, after discussing about this division by T and multiplication by T, let us recap the formula what we have discussed right up till now. Means Laplace transformation of multiplication means power of T we have discussed, and division by T. So if Laplace transformation of f of T is equals to f bar of S, okay. In case of powers of T, what is the formula? Means Laplace transformation of T power n into f of T is equals to minus 1 whole power n into d power n divided by ds power n into nothing but f bar of S. Whereas in division by T case, Laplace transformation of f of T means the entire numerator of the given fraction is considered as f of T, which is equals to integration over S to infinity f bar of S ds. So by memorizing these two formulas and observing whether we have this T power and powers of T in the given combination or not, otherwise division by T in the combination, we need to apply their respective suitable formula to evaluate their Laplace transformations. Okay. So till here, multiplication by T, Laplace transformation of multiplication by T and Laplace transformation of division by T have been completed.